and maybe this outs me as somewhat of a Java developer, but that's okay. So we're going to, there we go. Alrighty, so single responsibility. So solid. Single responsibility, open and close, the Linskov substitution, interface segregation, and dependency inversion. So this is where this is where we get into more of kind of the learning here. So what I'm going to do is I'm actually going to switch us over to the iPad so we can write this out and get a little bit more of a diagram going. Alrighty. So it looks like things are going good. So let's go ahead and write this out. So we have solid. Now solid is a principle for object-oriented programming to make sure that you are creating good, reusable, and well organized code. So let's go ahead and do this. So the reason for solid principles, again, it's that maintainable, understandable, and more flexible kind of thing, so that we understand how something interacts with a given layer or object or responsibilities in that domain, if that makes sense. So let's go ahead and write this out. So solid. What does solid mean? What is its importance? How is things? So let me get myself here. Use a nice purple because we're doing space themed. So solid. All right. So the first one is single responsibility. What does single responsibility stand for? Single response. So single responsibility is this idea that a class should have only one responsibility. And that responsibility is that if it does change, it's going to change for all of those classes. It's purely just for what it is designed for. So in this case, we are going to go with ship, right? Ship is we're going to start with ship as our class to work with. So we have, what is a ship, right? Go ahead and draw a little rocket ship here. I'm not an artist, and you'll quickly find that out. That I leave to my brother, who is a phenomenal artist. Change to red. We'll give it a little window here. But what is a ship? So this is our thing. So single responsibility. The class is so let's take what represents that as an object. So if we go back and take a look at our application here, and let's see if we can find some specs on it. So let's see. Open up the specs. Let's see what kind of properties a ship entity comes back with. So fleet get ship. Okay. All right. So we have some various things here. So what I'm going to do is I'm going to switch back to the iPad. I'm going to start writing these things down. So we have, let's see, we have data, which is, I think, more along the lines of what the who the ship will. No, that's the response. So we have symbol. We have symbol, which I'm not super concerned about unless I think that might be the name. Registration. So who does the ship belong to? Navigation. So this is, I think, an important one because this is going to be, this is how we navigate the ship. So how, let's see. Oh, I'm getting used to this. I'm so used to using a remarkable that using how the ship travels. Now this is interesting because when we think about the navigation, should that belong to the ship or should that belong to a separate, like maybe a navigation console, a navigation object, and then that's controlled. So you pass in the coordinates. Maybe the navigation is like where the ship is in space, or how is it moving around. But maybe for controlling the navigation, we eject that someplace else. So we'll keep that in mind as we run through an example here. And there's fairly interesting things here in navigation, like routing, destination, and origin, but we're going to go to crew. So crew, let's say folks on board, which is important because if you have Sigourney Weaver on your spaceship, you know that that spaceship is absolutely doomed. So, but we don't have anything like that. It's mainly just some things. So in there's some interesting fields like, let's see, we have current. So how many crew members are there? We have a required number of crew members to pilot it. A capacity. So what's the max capacity of crew members? A rotation. I'm not sure what rotation is, but we'll figure that out later. Morale. I'm gonna keep that off here. Morale and wages. And this is where things get interesting, right? Do we then create an entire object for crews? Like, do we say that a ship owns crew, and do we have an interface for that? I'm not sure. I think these are all these questions of like, how are we going to think about a ship? Frame. That's interesting. I'm not sure what exactly the frame is. So there is some things. We have a name, symbols, modules, mounting plates, fuel capacity. Oh, okay. Okay, so frame. The frame is it's literally the framed thing. So the superstructure is the way that I'm going to think about it. The superstructure, the right word? Like, I'm actually going to say it's more about the ship type. That's the way that it's a part of the ship. It's the fuselage. It's the fuselage of the spaceship. Hopefully I'm using fuselage correctly. I think I've watched that because the place where I get that is definitely from movies where it's more about movies more about things crashing, which might not be the thing that I necessarily want to associate here with no. Make that a very small rocket ship. There you go. Perfect. Okay. So we have our frame. This is where the other thing is reactor. So that reactor is that I find that important because the reactor is probably what is going to give us the differences of allowing us to travel. So this is the engine basic. Oh no, it's complete. Oh, it's the power center. Okay, this is the power center. The power center of our ship. So this is what's probably going to be generating us energy. We have an engine. This is how we get places. So our maneuverability, our thrust. So see, engine is kind of self-explanatory. I'm gonna just kind of leave that, but it does. So the requirements. So there's a requirements on this that changes your crew, which is cool. And then you have some modules. So this is the things we attach to the outside. Mounts, cargo, which is interesting. Fuel and cooldown. So we got a lot there, which is pretty cool. I'm gonna also resize this so it's on the frame here. We've got a lot of stuff to work with, and because we have a lot to work with, I think this is going to get really interesting. All right, let's put that there. Yep, that's all ding. All right, so now we have this idea of what a ship, or at least what the game considers aspects or jurisdiction is under a given ship. So, if we hop back here to our single responsibility idea, this is where the other thing is that this is very much a learning stream. So we're investigating it in a way that forces myself and those watching to really think about what are these ideas, how can we break them in and use them with how we conceptualize problems in the engineering space or things. I'm making this stuff up as I go along. It's all good. So what I'm gonna do is I'm gonna move this. I'm gonna cut this. I'm gonna put this on our next page. Right? So now we have our ship. And then what we can do is we're going to go back and we're going to break down single responsibility and then apply it to our ship diagram here. All right, so I'm going to go ahead and switch us back here. And let's see what we got. So it's a class, it's an object class. It's an object that has properties and then methods that interact with it. So for single responsibility, all right, so let's break this down and more, because sometimes, and this is the thing where it takes a little bit more to go into, because you can watch these things. I see the ad pop up, and you know what? I'm gonna just log in here off screen real quick because I'm tired of seeing these ads. One moment, please. Okay, here we go. That's a little bit better. Now we're not dying here because unfortunately, those commercials are great if it counted for all of you, but if it's just me, that's the thing. So a little bit of benefits. If you like Baildung, definitely go check him out. He is, I think, one of the best and leading authorities on how to use Java and specifically Spring well. So if you haven't checked out his site, definitely do it. It's baildung.com. And honestly, the pro is definitely worth it. Not having the the commercials, it really cuts down on the distractions. And additionally, fantastic courses as well. I've taken some of his spring courses. They're very well orchestrated and split up. So highly recommend. Definitely give it a look. Okay, back to the things. All right, so single responsibility. So the idea is that the class should only have one responsibility. Furthermore, it should have only one reason to change. So it's that lower coupling organization. So simple, broken down concepts. And it is small, it's self-contained, we're not bloating it. And interestingly enough, if we looked at our ship diagram here, that's a lot of stuff to keep track of. So I think my goal going into this, knowing that a big portion of this is organization and making things smaller for a single responsibility, is to make our ship class less of all of this and possibly finding out a good way to extend this and maybe use some other class for some of these ideas. All right. So back to streaming here. So in this case, it's using a book. The book has a name, author, and text. It has its constructors or getters and setters. And then as you can see here, this is where this is important. This bad example is where you're mixing the reason what the class is doing with what it shouldn't be. In this case, printing to the console. That's not quite the thing. You want to create a method of what should be printed to anything, not necessarily to do that action on top of it. And this is where that idea of how we can swap this around. So I think I mentioned earlier in the ship is instead of navigation being done by the ship itself. So if we were to take a look here, right here, this. Instead of the ship figuring out its own navigation, maybe we should have something called a mission control. Mission control, which handles the navigation of a lot of ships based on some other things. So is this another class that we could utilize? A mission control class that's job is to navigate ships in flight? Question mark? Maybe. I don't know. I think that's something that we should think about. Additionally, I think that maybe crew. Crew is probably actually something that we need to keep on the ship. Same thing for frame. I think reactor and engines, modules, mounts, cargo, fuel, cooldown. Yeah, but I think that's something to keep aware of, is maybe we have some alternatives there. Anyway, so single responsibility. So The idea is that this class's only job is to just specifically do work on the object itself, and it shouldn't be doing a lot of other things. So another one, so like if it was a cargo, like a trader, or some other things. So like if we're dealing with cargo on a ship, you would the class that you would actually use instead of using like the ship to do the interactions would be like a trader class or something like that, that is specifically for dealing with the cargo on our ship. But yeah, so we'll go back here. We'll go ahead and keep going. All right, so the O in solid is now that open and closed principle. So classes should be open for extension but closed for modification. In doing so, we stop ourselves from modifying existing code and causing potential new bugs. So in this case, it's using a guitar, and then what you're doing is that this is extending it. So in this case, this would be something like we have a ship class and we're trying to extend it to like a trader. This is a trader ship or exploration ship or something along those lines. So let's go ahead and we're going to hop back here and we're going to do our little thing. So single responsibility, a given class should only be responsible for one activity. I guess is things. What's the exact principle of things? Because there is importance in the meaning of words. Have one responsibility for itself. Oh, I did that again. I tried to erase at the back of it. I gotta be careful with that. So it's itself. And then moving on, so O, so open for extension. Modification, right? So if we were to, so we talked about like how a single responsibility. So for our ship, it probably shouldn't be responsible for its own navigation. We could probably outsource that to a different class, a class that is specifically only designed for navigation. Maybe we call it ship navigation. I think we called it mission control. But open for extension, this is where, our game flows come into play that makes sense for this. So we have a ship class, and I think that I'm going to adjust the camera here so people can see my face while I'm doing this. Or the top of my head, because seriously, that's what it's really going to be. There we go. All right, so our open for extension, closed for modification. So we want to extend it and maybe give some specialized interactions. Maybe there's a special navigation console or a special exploration class that has some methods in there to determine which direction the ship should go. But that might be under navigation. This is where that architecting of like how do we do this? So to kind of explain this, so we're gonna have our open for modification principle. Open for modification. We have our ship. You know what? Instead of drawing this, I'm gonna go copy it. So let's do that. Oops. So I want to copy this. So the idea here is now that we have this idea of a ship. So, but now we're extending it. We're saying like, hey, this ship, it's a special exploration ship. So this special exploration ship, you know, it has its own property. It shares properties with what is a ship, but well, that's not what I wanted to do. But that's okay. We're gonna just do this. It shares the same properties, some shared properties, but it has its own unique thing. So in this case, that uniqueness of the ship might be its frame, its engine, its modules, and maybe we classify a particular ship with some specific type of engine as as that exploration ship. So we're going to draw our little exploration ship here. And if you can guess where this comes from, I think you are on a good, you are very cultured. And we're going to say that I also don't know how to draw this, but that's all good. So we have our exploration ship here. So and it extends our ship, right? But additionally, we might have a ship that's not designed for exploration, but maybe this ship is, let's see, what's another one? We have let's see, we have a trading ship. So we could have that as well. So we have our trading ship. Now, a trading ship, let's see, what do we want to do for a trading ship? I'm always partial to the one from the Bebops. So let's see, we have our trading ship, and it's actually just literally, you can see my horrible drawing here. It's our space truck. That's right. It's a legitimate truck just in space. Fantastic. Draw a little engine there. And it's a going. Put some grills. Windshield. And it has little smokestacks. But that's the thing. So this exploration ship might have some specificity to it, some specific things that we classify, that we extended off of the ship. So maybe we have a module or some sort of like feedback mechanism or inserting of a exploration algo. So actually, you know what? It has a directive. So, say delete, cut. This one's gonna have a directive. Be prime. Whereas this one has a route list. Where it keeps track of its routes. What routes has previous routes? I think something might be more appropriate for this. Since it's attached to a given ship, it is something that the ship is defined by, but not necessarily something that the exploration ship might be worried about. So let's I'm actually going to do this. You have to bear with me as I get familiar with it. Right. Oh no. All right, so let me select these. Ugh, that's rough. Okay. Okay, yeah. So there's your open for modification, closed for modification. So that's the second part of this is closed for modification means that you can't just change the base class there because it might a route history for the ship might not make sense, but for and vice versa for the trading ship, a directive might not be the right thing. It doesn't have to follow the prime directive. It doesn't care about the prime directive. So close for modification, open for extension, and ooh, that's a thing there. For should we have our close for modification? So let's even make this a little bit cleaner. So I'm gonna delete these bits. So the parent class is open for extension. Wait, that's not quite what I wanted to do. We're gonna do this. Extend. I don't want to modify. Extend, but no modification. Extend, but closed. Anyways, we'll that's the idea there. So, whoops. Okay, so we're gonna keep that down there. So, L, the Liskov substitution. So, this is where I think things are getting a little bit more complicated. So we'll go ahead and slap back here to the stream. So the Liskov substitution is saying that if Class A is a subtype of Class B, we should be able to replace B with A without disrupting the behavior of our program, which is interesting. So how does that work? And how does that our idea of how what we have as being a solid model of a ship change with it? So we have a class model. For us, it's ship. And that thing has a set of methods that all ships should be able to do. And this one is saying we can turn it on and turn it off. By throwing a car without an engine into the mix, we are inherently changing the behavior of our program. This is a blatant violation of the Liskov substitution. It's been hard to fix in the previous. Solution would be to rework the model into interfaces that account for the engineless state of our car. So how should we describe this? What is a good way to describe this?
So, okay. So here's an idea. So, let's say we have our ship. No. I'm having a hard time just getting that ship, but that's okay. We will do something slightly different. So, let us say that we just are assuming that all ships have this ability to mine asteroids, right? So let's go ahead and create our rock here, which is a horrible thing. I'm actually going to redo this. We have a circle of our little craters. And then we're going to have our little ship. We'll create one with little fins. Horrible. Urgh. It's okay. I just need to get more being okay with the idea that oh, I have no idea what I just did, but that's okay. There we go. We're gonna have our fins, and then we're gonna have a little mining beam. Right? So, but the problem is that this takes into assumption that we now have this method called mine asteroid.
Now we're saying that all ships must be able to do this.
But what happens if we have that one odd ship that is actually a we're gonna say, look, here's our ambiguously non-copyrighted or definitely copyrighted ship. Come along. Now, this ship here, does not have a mining ray. So by us adding this mining array to our ship interface, it breaks that Liskov principle because not all ships can perform it. And therefore, it shouldn't be something that is on the original base class. I mean, theoretically, I guess we could have our turbo lasers here mine it, but it wouldn't be very effective. It's not really what we want.
Oh shoot! Oh no! I just drawed this entire thing out, and y'all are missing it. My beautiful drawings.
But that's okay. So this mine asteroid idea, this isn't really doable. So our regular ship might have it, but our warship here doesn't. So this means that this particular principle, this method, if we were to place on our base class, would break the Liskov principle. So, Liskov principle. all subclasses should be able to accurately perform the behaviors / duties, I would say, of the parent.
All right. So that's our Liskov. And then this furthers this idea that this mining that's going to occur would be something that's part of an extension, right? So if we wanted to add to make sure that we're not breaking the Liskov principle with our ships and in their mining, we would take the ship and extend it. So let's go ahead and extend it down here. We have a mining ship that has a method of mine asteroid. We'll go ahead and we're going to create a mining vessel. And I'm very partial to the very partial to, see if I can draw it. I'll have a little ring around it here. It's going to be connected by some superstructures, like so. We'll continue on back here. But then it's going to have, like, you know, a large section for mining gear. No. It's going to have some probes as well. We'll give it little probes. Right? Oh no, you can't see it. This is the reason why I need more people on chat. So we have now our mining ship that has a method. So that's how we're solving the problem of how we've broken the Liskov principle with extending our ship to create a new subclass of ship and making that mine asteroid be something that is only available for that ship, so that it doesn't break that all ships can have the same, should have the same, be able to fulfill the same behaviors. So we'll go ahead and mark this by extending ship. We can protect the Liskov principle. All right. Uh-oh. So let's go ahead and we're going to select these things and make it a little bit smaller. Okay. All right, so now we're on to I. So go back to our browser here, our things. Okay, so we have I. So this is the interface.
Segregation or separation. I'm going to call it interface separation. So our interface separation, interface I almost did it again. That's going to take a lot of time to break out of my habit.
So we have interface separation. So larger interfaces should be split into smaller ones. By doing so, we can ensure that the implementing classes only need to be concerned about the methods that are of interest of them. So the one that they have here is a bear keeper, which is very funny. So as valid zookeepers, we're more than happy to wash and feed our beloved bears. I love this. No choice but to implement the code and to pet the bear. So we are separating it out into 3 separate ones. So 3 separate interfaces. We're free to implement only the methods that mattered to us. So we're saying that our public bear class implements these other classes: bear cleaner, a bear feeder. And then we can, yes. So we're separating out different interfaces so that when a class is taking into those, it can take only the things that it needs. So let's go back to our example here. How could we separate out the problems that we are running into with the Liskov principle in the previous example of mining asteroids, right? So if we were to break this out, could we then assign specific interfaces for our given ships? And then we're saying that a ship is broken up and made up of those interfaces. And I think that we can. So in this case, we would have, say, a mining module would be something that we could apply to a class, right? So instead of just giving it an entire ship just mining, it has a mining module. So let's see if I can add a page in between these two. Let's see. No, that's not what I'm looking for. That's not what I'm looking for. That's definitely not what I'm looking for. Okay, so we're gonna just do this the old-fashioned way. I'm gonna take this. I'm gonna cut this. I'm gonna paste it down here. I'm gonna come up here. I'm gonna move all of our examples here. And then we're gonna move these down onto our second page. Like so. So we can add some more to this. Okay, so for our interface, our separation of interfaces, our interface separation, there we go. Our interface, oops, that's definitely not it either. So our interface separation, and it would really help, and I do that again.
Our interface separation is going to be something where we're going to split up some of the parts. So instead of us adding a whole mining ship, we'll have a mining module that we can attach to our ships. And we can see that maybe this is how we can change the logic, because we see all those modules that are coming back, and we can determine if the ship that we've received back from the API has a mining module. We know what class to pull from this. So let's take a look at this. So we have a mining module. So this mining module is, let's say, we'll make it a, we have a giant laser. But we're gonna make this a mining module, and let's make this a little bit more complicated. So a mining module is a class, right? But maybe there's multiple types of mining modules that we can use, such as we have our laser here. We'll go ahead and give it a nice green interface. The things, so we have our mining laser, but we might have a mining module that is drone based. So we'll have our drone hangar here. Oh god, this is awful. That's fine. And inside of our mining module here, we have various little drones. Various little drones that do our mining for us, right? Drone. So now we have two ideas here of our mining module, and this mining module will have a given method called mine asteroid. Now how each one of those do it is up to it. So this one, right? So this would be something, our mining asteroid, our mining module. So this would be like, mine asteroid would be like shoot asteroid. Whereas this one would maybe have two methods, and when it mine asteroid is called is would be issue orders to drone, issue drones, manage drones. All of that is underneath the mine asteroid. Right? And what we could say is, now our ship is now not based on are you a mining ship, but you could say that a mining ship must have at least one mining module. So we could have our ship here. We get real good drawing ships for this game. our ship here has a laser module that gives it access to that functionality. Right, so we have a ship that implements. All right, well, give me a second here. I'm going to go ahead and do this real quick so that we can keep going. So what we'll do is we're going to take a bit of a break while I deal with this, and I will also take a little bit of a restroom break as well. Okay, so we will be right back.
All right, and we're back. So, where were we? We were going over um, the idea of multiple of interface separation. So here we go. Now we have our ship, and it's implementing a mining module. So we're gonna oh no. So we have our ship, and the ship implements a mining module. Or maybe what we could do is we say it implements a mining a class of type mining module, but specifically we're adding a laser mining module or something along those lines. We'll figure that out later. All right. So now this ship has a function that contains mining. So maybe mining module isn't the right thing, right? The idea here is that it's implementing a particular set of methods that it should have. So this ship so maybe it's a mining ship implements laser mining. I like that. Right? So, and then mine asteroid would call, or might be, there might be that mine asteroid is now being done via a particular module. So I think we're missing something here that makes this a little bit more concrete. But we're going to, we're going to pioneer on. But the idea here is that having those multiple various interfaces allows us to separate concerns of how to do something, what something might need. So that's our ship, and that's our interface separation. So we'll go ahead and define this real quick, where larger interfaces should be separated not separate, should be split. So that we only implement methods we care about. Okay. I should really write with something slightly different. Anyways, we're on to our last thing here, which is dependency inversion. Now, the idea of dependency inversion is the idea of like it's not only decoupling, but it's you are sending in the necessary information to actually be able to do work. And this is really great for testing because you can say, oh, this particular class needs these particular modules and they have their own methods that are utilized, but they're self-contained, that single responsibility. So you can pass in a mock of those so that you can test your stuff without necessarily needing to implement it. So like a really good example of this is passing in your Axios client or your that's JavaScript. So I'm outing myself there as well. Gosh, I'm doing that a lot. You can pass in your whatever thing you want to, like, it is going to need to be mocked or tested so that you don't have to worry about it, and you can test just the behavior and responses and stuff of the internal method. So that's where dependency inversion becomes really, really useful. So D, dependency inversion. So let's go back here. So we have D. I'm going to start trying to I'm going to try and start doing some different colors here. I think that we also need to separate this out a bit more. Ah, I stole the P. There we go. So let's spread this out a little bit. That's not going to work. Okay. So dependency inversion. We're going to start with blue. So dependency inversion. Decoupling of software modules. So that dependencies are of abstractions which is good, right? That allows us to do that. So let's go ahead and oh yeah, here we go. Dependency inversion, things of distractions. All right, so let's go ahead and switch back here, and we'll go ahead and take a look at our stream. And so in this example, it's saying that there is a machine, and it has it's a Windows 98, so it's a computer, but it deals with a keyboard and a monitor, but those are separate classes that get handled. So that's where the dependency inversion is that you're putting them in. Now this could be done on a method base, it could be done on a class base. However you do it, it's the idea that you're separating those areas of responsibility to other classes, and then you're using those as part of your inputs, which is a horrible way of explaining it, but it's a good way to like things. So let's dive into this for our ship example. So how can we, and this is where I think the navigation, that mission control, starts to come more into play. So we made slight reference to it earlier, where we were like, you know what, this seems like a lot for a ship, so we should probably, and it's its own, there's probably a ton of that can be fit into that. So how do we do that? So let's go ahead and we're gonna go ahead and make some of these a little bit smaller so we can have some room to write. So we want, let's talk about navigation, right? So each of our ships clearly needs a navigation module or a navigation system for it to work properly. So this would mean that we can design a whole piece of software that is our navigation system. So let's go ahead and draw our little black box here. So we could have our little black box. Right? Or maybe we have a different type of navigation. Maybe we have something more sentient. We're going to give our friend here, we're going to create a, we're going to have a new, we need another color. Let's see, what's the right color blue for this one? This will work. Okay. And so it might be a black box or a old-fashioned computer. And then this one here is our, this is a navigation, but it is a artificial intelligence. And there's definitely rewards for people who can guess my my references here, but you know, that's fine. Okay. Then, when we are building our ships, we can say, this ship needs a navigation module. So, for one, we can inject the artificial intelligence into one of our ships, and that will be, and it will have its own set of things like navigate, you know, steer the ship, move the ship to various information, but how the actual methods are implemented is based solely on how the navigation module is done. So here we're going to have a ship and we're going to inject it. We're going to have it be injected into a ship.
So we'll have one for our super fancy advanced ship. So we have our this is maybe our cloak, our exploration stealth here. I like that stealth ship. So we have our stealth ship. And it uses that artificial intelligence navigation. So we'll go ahead and move this up a little bit so I can select this beautiful drawing here into our stealth ship. And then for our black box navigation, maybe it's a not so much of an advanced, ship. So it doesn't maybe it's not needed as much, but here is we're gonna inject this one into the other ship, and this one is going to be injected, and we have just a basic very basic ship that doesn't necessarily even need because that's what we just have for this ship. So this is our early ship, stealth ship, and maybe this is our early ship, right? So both ships required a navigation module, but the particular navigation module that we put into them may have very different implementations, which is artificial intelligence might have a way of navigating the ship that is much more sophisticated than maybe our black box, which is, again, I'm not using the right one here. Maybe black box isn't really the best thing. Maybe it's just a pilot or something. Anyways, this is the idea, is that now our ships aren't necessarily caring about how they're being navigated with their generic options. Those are implemented by our module, our class, our navigation class. So this is showing our dependency in our dependency inversion. So let's go ahead and add that. So we have our, let me scroll this up. So this is our dependency inversion. Injecting, injecting a navigation class.
Right?
Nice. So those are the 5 principles. We have our, let's make these really clear, right? So single principles, so ship, S, single principle, ship. The modification of which is our open for extension, closed for modification, which is O here, or O. Our Linkov principle, where all subclasses should be able to perform the necessary actions or behaviors of the parent class. So this is our L. we should be able to extend and separate and split up larger interfaces into large ones or into smaller ones, and then be able to implement those. Those are I. So interface separation, and then D is our dependency inversion. Which is where we can insert other classes so that we can keep things separated and responsibilities split up. There we go. That's solid. Alrighty. So, took a little bit